So let's start with the first slide. Is something that we like to repeat with our biggest customer that we have, and we work with them on the bigger project that we have in Arkansas, and it goes like the only reward for solving complexity in your projects, in your applications, is more complexity. Like, don't expect anything else in your projects, don't expect anything else in life. Like, if you manage to handle this level of complexity, the business is going to be like, oh, so now that we can do this kind of thing, we can try to do harder things, and they will go here. And there are two things that can happen. Either you still, as a developer, learn and grow when the application gets bigger, and you can still handle that level of complexity. But if that's okay, then the business is gonna go, so now let's go towards harder problem, let's have more customers, let's have more features, let's serve bigger market, more companies. So the story never ends. Basically, as long as you keep growing as a developer, as long as your team is solving problems, the business is gonna throw more at you. At some point, you might not be able to handle it anymore, and the project will stagnate a little bit, the company will be at this level of complexity, and adding things will be slower, changing the enterprise, the business will be slower, it will be harder. So that's the way of living, I believe. And what you can do with that in life is that you can either go to work for a big corporate, in big corporate environment, and then you're part of a team, the complexity is handled to you. Because older companies, bigger companies, they're often on the market for years, like 5 years, 10 years, sometimes 20 years, and there are still businesses there which are like 200 years old. They had 200 years to accumulate all the legacy, all the business rules, and like these conventions, how do they want to treat customers, how do they want to behave, and so on. Or you can go to startup, and the startup at the beginning will look very simple, it will look like very crowdish from programmers' perspective, and the complexity will appear over time. So over time, you will have the ability to grow with the startup that you are building. There's going to be more and more complexity, and you will need to grow as a developer. The businesses will need to grow as business owners. So my name is Robert Pankowecki, and I work at Arkansas as full stack developer. But recently I've been thinking about myself mostly as someone who tries to manage complexity. So we have these ever-growing applications which start simple, but after years they have 100 or 200 tables, models, a lot of things is going on. And what we as developers do, in my opinion, we try to manage the complexity of those applications. And what those applications do, they try to manage the complexity of the real world. So the world is complex, there's a lot of going on, we need computers to help us solve this out to be effective. That's what we do, but who handles the complexity of computers? We do. So how do we do it? We try to grow up as developers. We try to learn as many techniques as possible. So for example, DDD has some techniques for attacking, managing the complexity, like all those here that I listed. And today we will be talking about two of them, about bounded context and sagas. And like with every technique that you learn, it doesn't matter whether it's Railsway or these techniques, you gotta understand that these are just techniques, so you need to learn when to apply them, in which cases do they help you, in which cases they would do more harm than benefit. There is no silver bullet ever in programming. So you don't need to use all of them, you just need to use those that help you. And so you can read more about them in Vernon and Evan's book. Here's gonna be what I learned from them, how I'm using them, and how do they help me. So, bounded contexts. I fell in love with them. When I heard about them, when I realized how they map to my problems, what kind of problems they solve, I fall in love with them. So what does DDD tell us about bounded contexts? So there are these subdomains in our applications, like payments, or so I'm working on a ticketing application for selling tickets to conferences and events and workshops and so on. And we have these parts in our system like accounting, payments, like orders, and scanning, for example, scanning. And you might be thinking like, okay, why is scanning a ticket such a big thing that it's a separate thing, separate bounded context, separate part of our application? It's just like you get a ticket and you scan it. It's just so simple, like either it's scanned or not, it's true or false. Like where's the bounded context, where's the complexity here? And then you realize like the complexity is accumulated over the time. So then you learn, for example, that there are multi-day events. So you need to be able to enter on first day, on second day, and on third day. So you need to be able to enter multiple times. And there are events where you can go out, have a smoke, and come back. So you need to be able to come back, to be scanned multiple times. We need to scan you in, scan you out, scan in, scan out. Sometimes there are reasons to protect you, like we need to know how many people is here in the venue in case of fire, so we would like to be able to count how many people are inside. Sometimes, for example, on stadium, it's not enough that you came, that you have valid ticket, that there is barcode. You also need to come to the right entrance. So, for example, you need to use the entrance which is nearest to your seat. It matters where you go. You can't just use any entrance to enter the stadium. So the complexity is there. And over 2-3 years, when you hear more and more of such cases, it's getting bigger, it's getting harder. Like at the beginning, you think that, okay, I just have Boolean scanned ins or not. But after 3 years, you have this whole complexity, like a few models that are trying to help you decide, can this person enter this event or not? So the bounded context, they have their own language. They try to solve their own problems. And what DDD teaches us is that there is no one best, unique model that you can use in your whole application so that everyone is happy. It's possible that one part of your application will need to use one model. It will be a bit different than the other part of the application because they are trying to solve different problems. So here you might have something bigger, something more complex, and here you can have something smaller, which represent basically the same concept. But one part of your system does not need to know all the details, whereas the other needs to be much more informed to make proper decisions. And what that means is that here is something that we often imagine, like at the universities, at schools, at programming courses, we are often taught that, okay, look for the nouns and you will know the classes. So we listen to the business and we go to one person in our e-commerce application, and that one person tells us, oh, there is a product. So we listen, we hear, so we make a product. And we go to another person and they tell us, oh, I have a product. So at the end, what often happens is that we have this big product class and it's gonna have like dozens columns or maybe even 50. Like if I look into my user class at the product that I work on, there are 50 columns there. And people attending our DDD workshops, on some editions, they were like, how did you know? I just looked into my user class and there's also 15 columns. So it's not like a problem that is just imagined. A lot of Rails projects hit that line. And how do we get there? Like, this is what we believe we have. We think we have just product because we hear it all the time. But this is what we could have instead. Like you have a bounded context, you have a separate part of your application, and like for example sales, and sales has its own version of product class. And the other bounded context that you have, for example inventory, has its own version of product class. And pricing has its own. So you split it into smaller classes that are owned by particular bounded contexts, and those bounded contexts own the data. So it doesn't need to be a separate database, but it needs to be at least separate tables. So the sales bounded context writes here, and the inventory writes here, and the pricing writes there. And the inventory cannot just go look and read anything here or change anything here directly. They are separated. So this is something that let me fight with the problem that we have classes that are really big. And the funny thing is that the classes don't even need to be identical. So for example, in sales, you could have a pivorak t-shirt, and it's one product. It has colors, for example, red, green, blue. And it has sizes like small, medium, large, and it's one product. If someone looks in our shop for a t-shirt, they will find one product. But in inventory, that can be 9 separate products. You have small blue t-shirt, you had red big t-shirt, you have green medium t-shirts. So because here we think like, oh, it's pivorak t-shirt. But for the people working in inventory, for the people shipping this to you, like blue and green t-shirts are completely different things. Like I don't care that they're sold like on the UI similarly, like there are different products. So just because you hear one word, just because you think that you have something, and it doesn't need to be product, it doesn't need to be user, it's usually the most important class that you have or classes that you have in your project. So if you are working on HR application, that for example can be employee. In other parts, in other applications, this can be shop or something. So think about the nouns, the words that you most often hear in your projects and that keep growing and growing. These are more likely the classes that you would need to split, that you would need to discover that they are part of bounded context, that you would like to split things between. And how do you know when they communicate together that they are talking about the same product actually? Well, they can share the identity. So they can have the same product ID in all the parts. And so that's how they communicate. That's how they know that we are talking about the same thing in real life. So here's something that I also discovered in this project. So we have this class event, and it inherits from shop. Like, that sounds probably too a bit ridiculous. Like, event, like a conference, inherits from shop. That doesn't make any sense. And I had a lot of mixed feelings when I was looking at this code. Sometimes I was sad, sometimes I found it amusing, sometimes I found it funny, sometimes I was really depressed and angry. Like, event inherits from shop. What do I do with that? Like, how do I deal with it? But a few months later, it took me some time to understand what's going on in my project. How did I end up there? What happened? Like, not actually me, I was just like, we took this project from different developers. And I understood that there are 2 parts to my system. So we have this ticketing application which sells tickets, and in that world, the words on the left make much more sense. So we have organizer who creates events such as pivorak, and they sell tickets. And that's the right wording, that's what's happening, that's what's really important. But we have a lot of supporting concepts, a lot of supporting domains that we need to handle. So we need to handle reporting or taxes, accounting, and so on. And they're very generic. They don't really care what we sell. We could sell food, we could sell clothes. It doesn't really matter to them. Like, they just need to work with the rest of the system. And in those places, the words on the right side make much more sense. They're more generic, they are not so coupled with our ticketing application. So instead of event, you have shop, which sells some things. What does it sell? Sell products. Who sells those products? A merchant. So we have 2 things in our project. We have this ticketing part, which is really important because we sell tickets, but we also have this e-commerce part, quite generic, which does not need to know, does not care that these are tickets. It can be anything. So yeah, check this class, check other classes. and think like, do I really need 50 columns for my user to log in? Like, really, 50 columns to log in? Probably not. Probably what you have in your application is like, you have user, you have account, profile, administrator, customer, API client, and so on. Like, so there's a lot of ways that you can extract it and split it. And smaller models and clear data ownership, that's your way to go. And it's nice to have this, like, if you go that way, if you make those refactorings, or if you build your system from scratch like that, it's nice to have those separated, bounded contexts, like that you think that they are independent. But how do you make them work together? Because in some situations, to make some business process work, your application will need to have them all cooperate together. So how do we do? How do we reach this? So let's say we have our message-driven architecture, and we have two kinds of messages in our system. We have commands and we have events. So commands are things which try to achieve something. There are these requests to change something in our system. So let's say I want to book entrance, I want to reserve some seats. So my command is like, I want to reserve this seat. And either it works and I reserve this seat, or it didn't work and my command was rejected and something failed. So these are commands. And usually commands are requested in our system, executed by the users. The user use UI, tell to the system, do this. So that's a request, that's a command. And we have also domain events. And domain events are things that already happened, that they worked. This is, that's where they are in past tense. So for example, my command is a request like reserve something, and if it worked, I can publish domain event seat was reserved, or seat was placed, or order was shipped, order was booked, things like that. And here's what we can do. Here's like one way that we can use them. So let's say we have like one bounded context on the left, and we have another bounded context on the right. And whenever this bounded context publishes domain event or so-called fact here, something else in different bounded contexts can react to it. So that's one thing. But the other thing that you can do in your application is that you can have sagas. And I'm going to tell you about sagas by using examples. So here is one saga in our system, send PDF via postal. And here's how it works. You have 4 domain events that need to happen in your application, 1, 2, 3, 4. And you have one command that you would like to happen when all those domain events occurred. So we have this feature that you can request for tickets to be printed and sent to you via real mailing system, like using a postal office. Like real postal man comes to you, prints the tickets, and handles them to you. Like not many people use that, but some do, because they want the convenience of that. Maybe they don't have a printer, maybe they don't want to take their mobile phone with them to the concert. So what they do, we have this add-on so that they can ask for printed tickets to come to their home. And how does it happen? So first you need to add the postal add-on to order, then you need to fill out the address, and we need to generate the PDFs of those tickets, and finally you need to pay for your order. So if all that things happen for one order, then we can issue the command send PDF via postal, and it has all the data that it needs. So it knows which order, it knows which PDF, it knows the address, so everything can be used to trigger a command. And this is interesting story because this time it's not a user triggering a command in our system, it's not the user asking for something to happen, it's the system itself. It listens to what's happening in all our contexts, on all our bounded contexts, in everywhere. It collects the data, and when the right moment comes in, when everything happens necessary, it sends a command And it's also interesting that those domain events, they don't need to actually happen in this particular order. So for example, if you are very quick with providing us with your address or use browser autocomplete, then it's like very quick and it might be faster than how long it took us to generate the PDF. But if you are a bit slow and we just generated the PDF in a few seconds and it takes you longer, then maybe you will provide us with postal address later than the PDFs were generated. But the Sagas don't care. They just want all those 4 things to happen so that they can send a command. So here's a different example how we use them, how we work with them. In the ticketing industry, there's this concept that you have limited amount of time to pay something, to place an order, and to finish everything. Because like with high selling events, with things that are popular, like Pivorak or like Wrocław RB or Adele concert, there's a lot of other people who would like to buy their ticket instead of you. So you have, for example, like 20 or 30 minutes to buy. And in such case, we expired the order. But it's possible that you went through the whole process, you landed on payment gateways page, maybe you went to lunch, maybe you were looking for your credit card for so long, and the order expired, and then you come back to us, to our system, with information that payment was paid. So what do we do? So in this situation, we trigger a command, release payment. So the payment bounded context receive a command, because when payment is paid, it doesn't actually mean that it was paid. It means that the amount was authorized on your credit card, we have the amount blocked, and we can either capture it later or we can release this amount. We can decide as a merchant, as a system that, okay, it's nice that you reserve this money for us, but we can't deliver this good, we can't deliver the order, so could you release the payment? And that's what we do in this situation. And something appeared here, I don't know, something stopped working, but I hope I'm gonna handle it anyway. Yeah, I am. Yeah, I know all the story to the end, so no problem. But here is a successful scenario. So we have order placed, we have payment paid, and then we have a domain event that, okay, the order was delivered. We managed to deliver the virtual goods to the customer, in our case, the PDFs of the ticket, for example, via email. So what kind of command would we like to issue in that case? Capture payment is released to payments bounded context. So again, we have domain events from 2 parts of our system, from orders and payment, and when enough of these things happen, we tell to one context, okay, capture this. But that's still not the whole story with payments. There are more cases that can go wrong. So even if order was placed, even if the payment was paid, we can have a problem with delivering it. So we might have domain event, order delivery failed. So the order didn't expire, but when we tried to provide the customer with what we promised to him or her, it didn't work. So again, what's the command? Release payment. Nothing fancy, nothing hard. Here's an interesting scenario. We have the ability in our system to pay with invoices. But they are handled like quite manually, like half automatically, half manually. There are still some problems with it. Apparently, sometimes businesses assume that people can copy-paste like a invoice reference number or invoice ID into payment details in your bank. Trust me, 50% of customers will fill out it with something else. Like, you don't want to have manual payments for invoices and matching it in bank account statements. That's actually tried and not working. So here is a situation. Order was placed, we issued an invoice. Someone has, for example, 20 days to pay for it. And what we also did is but they didn't pay in 20 days, so we issued credit note. Credit note is like the reverse of invoice. So it says like the invoice that we gave you before, it's no longer valid because you didn't pay us. So we issued a credit note. And then one day later, we realized, oh, the invoice was actually paid. Because we realized it later that because there was some delays in processing, in figuring out, and maybe the customer called and told us, so we put it in our system that it was actually paid. We manually checked it, and we delivered the order. So we delivered the order, but the customer has invoice, the customer has document which says the invoice is no longer valid, but they ask for invoice. So what we do, we send a command, issue new invoice. And the funny thing is the command is not even handled like the job behind it is not handled automatically in the system. It's such a rare case that the command actually triggers mailing, and we tell the accounting people, you know what, we had this very rare situation, we had an invoice, then we canceled it with credit note, but the person actually paid and we gave them the tickets, so could you maybe manually generate them, now the right invoice, that everything will be okay? It's a long business process that takes like 14 or 20 days. A lot of things need to come up, accumulate for it to happen. Okay, here is a different example which I really like and enjoy. So let's say we have this business rule that if we ship 3 orders in 30 days, someone should get a discount. And that's sometimes a hard problem, because how would you do it in your current architecture? If you were to design something like that, how would you solve it? Like, think about it for a moment while I drink water. So the usual solution is to use some kind of cron job, looking back over 40 days, like 30 days. So every day at night, we run this magic thing called cron job, and it asks our application, hey, could you look 30 days back whether this customer has 3 shipped orders? And by the way, could you do it for all customers? So we have this batch process trying to do it. That's the usual solution that we have. But there is a different solution that I really like, because what I told you before, the solution with cron job is looking into the past. So we are like, instead of looking into the future, instead of reacting to things, we are trying to look into the past, what happened in our system. But here we have a different approach. So order is shipped, and then we schedule something. We scheduled a domain event to happen in future. So in 30 days, there will be domain event happening, order discount point expired. So they got 1 point for the order that was shipped, and in 30 days we schedule that it will expire. So we have, for example, a REST scheduler for that. You just tell it that something should happen in 30 days, and in 30 days it will call your application and tell you, oh, do this. So that's what we are doing. So we have 1 point, and for example, in 30 days, we go from 1 back to 0. And then customer orders something, it was shipped. Customer orders something again, it was shipped. They order again, it was shipped. And now they have 3 discount points, and we realize, okay, random discount. Use the command, send command to the discount bounded context that this customer should now receive a discount. So this time, instead of thinking back in time, we are thinking future in time. Like, we are just reacting to what's happening now, and also sometimes scheduling domain events to happen 30 days in future. And yeah, so you might be thinking, well, but 30 days later, when the previously scheduled order discount point expired things come in, they will go to -1. And that could be a problem if you implement it incorrectly. But if you just keep an array with the IDs of orders, and when you grant discount, you clean it so it's empty, and then comes like later order discount point expired, and you try to remove the order ID from the empty array, it's still empty. So you are quite safe. It's not a problem. It's just a matter of implementation. And here's typical examples for Saga that is always used like since 1970 or something. So you're trying to book a trip. You want your trip to be really successful, enjoyable. Maybe you work longer, hard with your spouse to buy these vacations. So you want three things to happen. You want to book a plane, hotel, and car. But usually those kind of systems, they are very big, they're very complex, and you usually don't have one system which can do all of that thing like in one database transaction. What you usually have is like one API provider, second API provider, third. There are three completely different systems using three completely different databases. So how do you handle the situation that if something fails, you want everything to go back to normal. You don't want anything if one of those things fail. So the answer lies in Saga. So you have a domain event that a plane was booked. We start with the hardest thing to book. Then you have a domain event that, okay, hotel was booked. And then you get a third domain event, car booking failed. It didn't work, sorry. So what do? We undo our previous steps. So we send a command unbook hotel to the hotel system, and we send unbook plane to plane system, and we go back to 0. So I think that's it about Sagas. No code, because I wanted to show you like very high level overview, how that kind of things work, in which scenarios we use them, for what, like, how can they help you? Yeah, I think that is. Do we have any questions, maybe? Do we still have time? Yep.
That's all?
Yeah, that's all. Now it's 15-minute discussion. Yeah, go ahead. So how does the Saga know that this thing happened, that we booked plane? Oh, so usually the implementation is done in a way that the ordering does not matter. So for example, if I have a plane booked, a car booking failed, and I undo plane, and then comes information hotel booked, then I will realize, okay, but I'm still in the wrong state. I still couldn't do all of them together. So even though they came in different order, I would issue unbook hotel. So you implement them in a way that you don't care. And the way I try to establish, the way I try to make sure of that is that I often, like I started using, after I was burned by some use case in my application, I was thinking like, I have all the corner cases covered, I have all the possible combinations covered, my implementation is great. And then of course, I figured out I had a problem, I had a bug. Like in 12 cases, 10 orders worked. So, but 2 of them not, and I didn't think about them. So what I do right now in code when I test my Sagas, when I test them, is that I put the domain events that I want to test, like ABC, and I use Ruby arrays method permutation to iterate over all permutations of all possible permutations. So before I sometimes had like a random order, but if there is a problem like in one of 20 cases, then you will have a random failure on your CI, and you think, oh, that's random, and you retry and it all works. So you won't even notice such a rare bug, because you will be thinking, oh, it's just random, retry. But then when you iterate over all cases, you will see, okay, 19 cases working, you forgot about case number 20. And so that's how I try to make sure that the order does not matter. And what I also try to check is that I duplicate some of those events because depending on what kind of message queue you are using, you can sometimes get messages duplicated, right? So that the message queue is sure that you received it because, for example, they didn't receive the confirmation. So I also just add like duplicates, and I'm testing that with duplicates, I send the command only once so that I handle idempotency properly. Okay. Yeah?
So I have one more to this slide.
Sure.
It looks like the entity for this saga is user.
Is what?
User. Some people are customers.
Usually the way that you would correlate those events, so in this case probably it would be by order ID. So each of those domain events would, for example, have order ID, and that's how you know that they are all related together, and that's how you can find the state.
So if the order is the main thing for this saga, but we need to handle plane and hotel. So what do you use? Do you use two or three streams here, or?
Two streams?
Yes.
No, it would be just one stream. So the Saga is listening to all those domain events, and it keeps the state like grouped by the order ID. So if you use domain events and save them using event store and using streams, then it would be like you would copy them to the same stream so that you know about them. If you just store the state on database, then you would find the state on database based on the order ID from those domain events. Yep. Go ahead.
Can you show the code?
Yeah, I can show you later the code. Like I wanted to have a higher level look, but of course I can later show you the code. Like, yeah, it's not even my Mac, but I can show it later. No problem. Sure.
For 1 second.
Anything else? No. Okay. No problem. I think we have small break now, right?
Maybe you have a question for yourself?
Not right now.
Okay, thank you, Robert.
Thanks.